Many natural phenomena use exponential or exhibit exponential decay and growth. This is one of the most common forms of change there is, right next to linear and other similar functions. In this case, we'll be looking at, in Chapter 5, in the review problems, problem number 65, looking at the decay of polonium-210, which has a half-life of 114 days. The only important thing to realize is that polonium, well, all radioactive materials, decay with an exponential decay rate. That means that they decay according to the function A final equals A naught times e to the power of kt. Now, if k is a positive number, then that means we have growth, because as t and k become larger, e to that power becomes a very large number, and you have a growth situation. Whereas if k is a negative quantity, then as t becomes large, k times t becomes a very large negative number. E to the power of a large negative number becomes a very small number. So when k is negative, then this becomes A final becomes a very, very small number. Approaches 0, but always positive. In this case, we have 10 milligrams of polonium-210. We know that the half-life is 114 days. We want to find out how much is left over after a year. Now, in this case, we need to have consistent units. So, if we have 114 days for the half-life, for 1 year, we will need to use 365 days. Now, what we first need to do is calculate what k is. We'll do this using the half-life. So we start off with 1/2 of A naught equals A naught times e to the power of k 140. I set time equal to 140 and a final equal to half of the original. What half-life means is that after that amount of time, we have half of the original material left. So if I divide both sides by A naught, then we get 1/2 equals e to the power of k 140. If I next take the logarithm of both sides, then we can simplify the right side, because the logarithm and the exponential are inverse functions of each other. That means each one undoes the other, meaning we are left with the natural logarithm of 1/2 times k to k times 140. We can rewrite this as natural log of 1/2 over 140 equals negative 4.951 times 10 to the negative third. This has units of 1 over day, or 1 per day, because our time unit was in days. And kt must be dimensionless. You can't have an exponent with a unit. So, now that we know what k is, k equals this, we can take our original change formula. A final equals A initial, the original amount, is e to the power of kt. A final is 10 milligrams. K is negative 4.951 e times 10 to the negative third. Our time is now 1 year, because we needed to solve for how much was left after an entire year. From here, we can simply solve this in a straightforward fashion. So first we solve what the exponent is and take e to that power. We get 1.1641, of course, times 10. 10 times that gives us a final amount of 1.641 milligrams of polonium-210. So after a year, this is all that we have left. It is a short-lived material.